Hi everyone, I'm Aman and today I'm going to talk about our paper, Could You Give Me a Hint? Generating Inference Graphs for Defeasible Reasoning. And this is a joint work with Dheeraj, Niket, Iming and Ed. So I'm going to talk about two things basically. I'll introduce defeasible reasoning and then I'll talk about graph generation. So defeasible reasoning setup is as follows. We are given a premise P, say a contagious virus is spreading. We are given a hypothesis H, say Rob catches the virus. And then we are given some new evidence which may increase or decrease the probability of the hypothesis. In this case, as we can imagine, U strengthens H, but for some other update, say the virus has lower infection rates, U may weaken the hypothesis. The task itself is quite old, but last year, Rachel and others introduced a large data set for this instance of defeasible reasoning. The basic idea is that humans find it difficult to solve this task. Can we add more information to each defeasible query to help this situation? So for the given example, maybe there are two kinds of extra input that we can add. So first would be a mediator that kind of explains why the update affects the hypothesis in the way it does. And then there could be some external situations. So the key contributions are that we present a method for constructing so-called inference graphs. And we find by our human evaluation that these graphs actually help humans at defeasible reasoning. Now let's move on to generating these graphs. So in an ideal world, we would have a parallel corpus of defeasible queries to graphs. Short of that, we kind of leverage a related corpus called Vika that also contains passages and graphs and kind of form a loose mapping from defeasible to Vika. We train a T511 billion parameter model on Vika to go from passages and some nodes to the graph. And then we run this basically inference on a defeasible query to generate one graph for each defeasible query. Now to see if these graphs help humans, we use the same human pool, evaluator pool, and show these graphs to humans in addition to the queries, and humans find these graphs to be helpful 47% of the times. And more importantly, these graphs actually help human performance by 20 points on average. Different parts of the graphs were useful to humans to different degrees. Mediators were found to be the most useful. So in summary, model-generated graphs can help humans at defeasible reasoning. These graphs are available at this URL for you to access. Thanks.